In examination we will ask question like what is virtual ground in operational amplifier. We know about ground means when connected to a very low potential or zero potential, it is called ground. Then what is virtual ground in operational amplifier? Virtual ground means the circuit is connected to a very low potential or zero potential, then it is called the virtual ground. So how virtual ground is taken in operational amplifier? In the previous video I have told you about inverting amplifier and non-inverting amplifier. That is, in operational amplifier you have inverting amplifier and non-inverting amplifier. Inverting means the signal is connected to the negative end, and non-inverting means the signal is connected to the positive end of the operational amplifier. So in case of, now we'll discuss about the inverting amplifier. This is your inverting amplifier, and in inverting amplifier I have told you the input is given at the negative end and the positive end is grounded. You see, this is the positive end and the positive end is grounded, and the negative end input is given. Vi is the input voltage or the supplied voltage. So supplied voltage is connected to the negative end and the positive end is grounded, and this point G, this is called the voltage. Here is called the voltage at the inverting input terminal. Okay, so V is the voltage at the inverting input terminal and Ri is the input resistance. So the applied voltage, the supplied voltage, that is Vi, is not equal to the voltage at the inverting input terminal. This will differ. And here RF, as I have told you in the previous video, it is the feedback resistor. So in inverting amplifier you have input voltage and you have output voltage. This is your output voltage, this is your output voltage, and you have a voltage called at the V is the voltage at the inverting input terminal. Suppose the gain of the amplifier, that is the open loop gain, is equal to A. So if you have no feedback, then that is called the open loop gain, and the open loop gain suppose equal to A. So A is equal to output divided by input, and output is equal to V0 or V0, and input is here voltage at the inverting input terminal, so V0 divided by V. And in the previous video I have also discussed that the open loop gain of the operational amplifier is very high. That is, the A, magnitude of A is very high, so you can take it as infinity. So what will be the voltage at the inverting input? So voltage at the inverting input V equal to output voltage divided by gain. If gain will be equal to infinite, then voltage at the inverting input terminal will tends to 0. Okay. And I have told you when the voltage will be equal to 0, when the circuit is connected to the ground. But here you have not connected the circuit to the ground, but voltage at the inverting input terminal is equal to 0, because the gain is equal to very high, that is infinity. That is why the inverting at the inverting terminal voltage is very large. So the inverting input terminal is practically is at the ground potential. So you see in this circuit, the inverting terminal is not connected to ground. This terminal is not connected to the ground. The positive terminal is connected to the ground. But this terminal, the potential at the inverting terminal is equal to 0. That is why this terminal is called the virtual ground. Though it is not connected to the ground, but the potential tends to 0. That is why it is called the virtual ground. So whatever may be the input voltage or whatever may be the output voltage, the voltage at the inverting terminal voltage is equal to 0. That is why this is called the virtual ground. So question will be asked in the examination that what is virtual ground. So you should write the voltage at the inverting terminal is very small or nearly equal to 0 because of the gain of the amplifier, inverting amplifier is very high. That is why it is called virtual ground. Though it is not connected to the ground, since the voltage is very small, so it is called virtual ground. Thank you.